Okay, in this calculator problem, it's going to ask us to find some angles at which a ball can be thrown to make it a certain distance. So here it says distance D. So distance D, that's going to be this value right here, in feet, describes the horizontal range, so the horizontal distance of a thrown object. It depends on the initial velocity at which the object is thrown and the angle above the horizontal. So you've got a person, we've got a horizontal, and that's going to be your horizontal range that we'll just call range. And when you throw a ball, usually you throw it up at an angle. So we could throw it up at this angle, and then, what goes up has to come down. We could throw it at a higher angle. What goes up comes down. We could throw it straight up. What goes up, what comes down. So you can throw it at all sorts of different angles. And you know that if you want it to go the furthest, if you want to make it this far, if you throw it up in the air really, really high, you're going to have to do it with an initial velocity that's pretty high so that it still makes the distance. Versus this angle right here that you're throwing the ball. And when I say angle, I'm talking about this angle at which you're throwing the ball. So you're going to throw the ball somewhere between 0 degrees and 90 degrees. We want to find the angle that you can throw that ball with this formula right here. Okay, so we're going to use that formula. So that's what the first paragraph says. Now it gets into the nitty-gritty. You and your friend are throwing a baseball back and forth. If you throw it with an initial velocity of 90 feet per second, 90 feet per second, at what angle of elevation should you direct your throw so it can be easily caught by your friend who's 170 feet away? So the horizontal range is 170 feet, and now there's a person at the other end, and you want it to get exactly to them. You're going to throw it up at an initial velocity of 90 feet per second. Initial velocity is this V naught right here, and that's 90 feet per second. So the formula says D equals the initial velocity squared. Initial velocity squared, so I'm picturing 90 squared, divided by 16 times the sine of theta times the cosine of theta. And this distance right here describes the horizontal range. So that distance is 170 feet. So at this point, we're thinking we can just plug this in and figure out what our answer is, right? We've got D equals the initial velocity squared over 16 times the sine of theta times the cosine of theta. I'm going to plug in my 170 for my horizontal range. I'm going to plug in 90 for my initial velocity, so I have 90 squared over 16 times the sine of theta times the cosine of theta. Now, when I was thinking about this, there's a couple different ways we can do this problem. When I was thinking about this, I was thinking, I really kind of want to get sine of theta, cosine of theta all by itself on one side of the equation. So what I did was I multiplied both sides by the reciprocal. So I multiplied by 16 over 90 squared, 16 over 90 squared. So my equation became 16 times 170, or 170 times 16, all over 90 squared, equals the sine of theta times the cosine of theta. And then I thought, what can I do here? Well, I can solve this by hand, but eventually I'm going to have to pick up my calculator anyway. So we should be able to put this into our calculator. This is y1. This is y2. And let's see where the two graphs meet. Where do they intersect? That's going to be our solution. Remembering, though, that our angle, theta, has to be less than 90 degrees but greater than 0 degrees. Because when you throw a ball, you're not going to throw it backwards. You're not going to do 120 degrees because it's not going to go towards the person that you're throwing the ball at. So between 0 and 90 degrees only. Since I'm in degrees, I'm going to put my calculator in degree mode. So here we are, we're in degree mode, and I put the left-hand side of the equation in for y1, and I put the right-hand side of the equation in for y2. And then I went to Shift F3, and I have a standard window. So if I don't have a standard window, I'm pressing standard to make it a standard window. Now I'm going to think about things. X is my angle, that's my input. I want an angle between 0 and 90 degrees. I'm going to go up by 15s. It doesn't really matter what the scale is, so you do whatever you're comfortable with there. And then I'm going to let my calculator auto fix my range by drawing with the given domain that I want, and then hitting zoom auto. And we've done this before, so hopefully this feels familiar. So it looks like there's two solutions. So I'm going to hit G-solve intersect. One solution happens when my angle is 21.096 degrees, 21.096 degrees, and the other one occurs, hit that right arrow and it jumps over, it takes a second, 68.904. 68.904. So back here, I've got two answers. Theta's 68.904 degrees, but before it was that, it was 21.096. 21.096 degrees. So there's two angles that's going to achieve that. One is the lower angle, and the other one is going to be that higher angle. The one in the middle, my guess is if I use this one in the middle, right here, it's going to, with the initial velocity, it's going to go past. It's going to go past that guy. So the one in the middle is not going to work. So I'm going to delete that out of there. That one's not going to work. So why, now just out of curiosity, why at 21 degrees will it go the same distance as 68.9 degrees? Why is that? Well, if you're throwing it at a lower angle, you're probably going to get that distance right here, right? But it's kind of difficult to throw at that small angle above the horizontal. So you're going to have to get that thing going. Now up here, it's going to happen at 68 degrees, and it's not going to bypass because a lot of that initial velocity is going to be taken and going up high, so it's going to fall down and plop right in front of whoever you're playing catch with. So two answers for this problem. Using your calculator, so a combination of plugging, chugging, using your calculator, but really understanding this part right here. When you throw a ball, when you hit a ball, when you're playing soccer and you're kicking, you're going to kick everything or throw or hit with a baseball bat between 0 and 90 degrees. You can't go over 90 degrees, otherwise you're going backwards. It's very awkward, and it doesn't work.